So yeah, welcome to Women in GIS for our March 2026 Lightning Talks, brought to you by Women in GIS Professional Development Committee. So what is Women in GIS? I know most of you are already very familiar with us because I see a lot of names that usually join us on Lightning Talks. But I'll just quickly give you an overview for the people who are joining us for the first time today. And thank you for that. We are an international organization of inclusive women and allies coming together to provide resources and opportunities for success as you navigate your geospatial career. Good thing is everyone is welcome here. We are big on networking, so drop your LinkedIn in the chat and get connected. For today's lightning talk, I'm your host. I'm Rupsha Roy. I'm a technical specialist with a firm called Weston Sampson. I am based out of Boston, which is significantly cold right now. And I'm the chair of Professional Development Committee and a proud member of Women in GIS. If you're interested in volunteering with for any of our committees, we have some amazing committees. Please check our website and please become our member and join. We have some great committees that including professional development, outreach, and so many other committees. Please feel free to volunteer with us. We are always looking for volunteers. We have some great group of women who run those committees. So you're welcome to join us. Our lightning talks always takes place on first Fridays with just one topic, GIS in action. So it does not have to be uh, any GIS topic all the time. It can be how you navigate through your GIS career. Anything related to how your spatial work and your life around your career with spatial work. We could not thank enough our sponsors. Esri Esri is our platinum sponsors. We cannot run our organization without this sponsorship. So we also have a bunch of gold and other sponsors that you see on the screen, and their sponsorship means a lot to us to run our organization. Let's give them a shout out for additional sponsors. We appreciate all their continued support. And then and I'll move on to our next slide, which just says for our next presentation before we jump onto our presentation today. Our next presentation for Lightning Talk is April 3rd. At the same time, we hope to see you most of all in that presentation. And without further ado, I'll just jump into our conversation for, can I stop sharing? Yeah, I will, I'll let our speakers speak for themselves. We have some three great lineup of speakers. Sam, who is also happened to be one of our board members. Jami, who is our outreach committee chair and an amazing board member. We have two great women that are part of YGS. And then we also have Kaylan. She's also going to be presenting with us. So I will let Sam take it over, introduce our topic, and introduce yourself, Sam.
Hi everyone, I'm Sam. I'm going to try to multitask um, while I share my screen and I click the share button. Okay, what can you guys see? You see my whole PowerPoint right now, right? Okay. And then I want to go to minimize this. Oh, oh, come on. There are too many things going on. Okay, I want to present. Present. There we go. Oh, it's not going to show me my notes. We're going to do it on the fly. All right. Can you guys see my screen? And I can't see you anymore. So, oh wait, maybe I can. Yes, now I can see some of you.
We see it. We see
Okay.
your PowerPoint slide, your title slide.
Perfect. That is what I wanted. Okay. Hi, everyone. I'm Sam. I'm not feeling super great today, so this is what you get, and the couch background is what you get too. I am very sorry. I'm not being very professional. Um, So I work for Pima County, which is in Tucson, Arizona. In the Development Services Department, we do lots of like building permits and land use and parcels splitting and rezoning and that kind of thing. If you have any questions about what I do, you can connect with me on LinkedIn. I'll post my thing after my presentation. Um, One of the projects we worked on, Ripsa, you'll have to yell at me if I'm going too close to time. Um, so one of the projects I just completed yesterday, um, so this is already sort of out of date, is a subdivision plat review dashboard. Um, so, ooh, click. There we go. Okay. Is that my first slide? Woo. Yes, that's my first slide. Okay. So, most of us know subdivisions are like pieces of land that have been divided. Sorry if you can see my teams. Divided into lots and streets, and they make up a little like neighborhood or a big neighborhood. We had this very convoluted, long process in Pima County where you have to apply for this, and then you apply for another thing, and then you have to turn in like a tentative plat, which is like a draft of what you want to do with the land, and then you turn in a final plat, which is, what you're actually going to do with the land, and then it has to go through our department, which is Development Services. It has to go through the Board of Supervisors, which is like the governing board of like the whole county. It was very convoluted, and we recently passed a policy to make it slightly less convoluted. Um, so this picture on your screen is what a plat would look like. It'll have a little location map where it'll give you the location, what's in the vicinity. It's also called a vicinity map. It gives you all the information about the easements and the permits and the lot sizes and everything. So to make our process slightly less convoluted, we cut out the part of the process where it has to go through the Board of Supervisors. Um, but when you don't go through the Board of Supervisors, you don't have an agenda item. So the neighbors, so the people who would live kind of around where this building construction stuff is going to go on, don't really know what's being built there, why it's being built there, what is being built there, if it's commercial or residential, how many lots, all these things. And so we are trying to be very transparent with our customers by creating an application that will show them all this information. So, on to the GIS fun. I'm moving you guys, sorry. So I can see my slides. How did we do this process? So basically you have to get all of these plats, which are little pieces of land, into a map. And then we're going to share some information about them. So the first thing you do is you download this lovely CSV, which I'm sure you guys are all familiar with CSVs and how beautiful they are. Just raw data. We downloaded it from Acela, which is our permitting database application. That's where the magic happens, where all the information goes. So I got a big list like this of like 60 plats, and then it's really small, but the first column is the permit number. That's the bold in the second picture. And then you have your little details, your title, your information. So I would search for the documents in the database, and then I had to create these polygons. So most of the time there were parcels that built out the exact shape of the plat. Either one parcel would equal a plat, or there would be multiple parcels that equal a plat, and I could copy, paste special, and then merge them all together and get one piece of land. Um, some of these were not very pretty, and I had to digitize the outline using Kogo tools. If you don't know what that is, we can chat later, but it was basically my first job in GIS when I was a GIS technician. It was you put in the direction of the line and the length of the line based on the survey, and it builds out the polygon for you. And if you mess up one of the lines, it's really frustrating. If there's curves, they get really complicated and frustrating. It's great. So much fun. And then once the polygon's placed and built out, you fill in the attribute information. So your permit, your address, your parcel, the record name, which is just the name of the subdivision, the description, the status, and the type. And turns out yesterday at 4 p.m., I realized I needed a date field as well. So that is today's project, is adding dates to all of these. So, once you get a beautiful layer, we'll go back one real quick. Once you get this beautiful layer of polygons, it goes through all the ITGIS stuff that it needs to go through to get uploaded into our spatial databases, our open data for the public and other where all the places it needs to go so we could build a web map. So, first part of building a web map for me is always the Pima County boundary, the street network, and the parcels. That's just because I work in development services, so we always need at least those three things. You may, if you're building a web map, may need other information. Um, that was kind of my base, my context. And then I added this subdivision plat review layer, which is the layer I just built, in Pro. Um, and I added a filter on it. So I did, one copy is final plats and one copy is tentative plats because they wanted to show them differently and they wanted to have different data on each of those things. So even though it's one layer, it's in there twice with a filter on it. And then I also labeled the final plat record names. I'm pointing to my screen. That's not helpful. The final plat record names so that the general public knew what they were looking at when they look at this web map. And then this is the meat and potatoes of the whole project. So we built a dashboard. And so this dashboard shows our layer. It shows our web map that we just went over with the parcel streets and the final and tentative plats. On the left-hand side, I know it's kind of small, sorry. You can search and select plats based on their name. The top row, I guess, is final plats. So these are things that have been approved that they are getting built. And then the second row is tentative plats. So these are kind of still in process. Once they get approved, they'll go on to final plat stage, and then they'll go through the review process again to make sure they're solid and what we want to build, where we want to build them. Each one of the attributes we filled out was number of lots. So calculated from final plats, we have a total sum of all of our new lots. We have a pie chart that Jami might yell at me for because it has 7 categories instead of the maximum of 5. But I think it's still pretty readable. We'll see. We'll get Jami's opinion. Um, but those are the statuses. So the final plat, it's not just like here's your tentative plat, it's approved, and then here's your final plat. You have to, you turn in your paperwork, and then there's if the paperwork is complete, then it's submitted, and then we review, development services reviews it, and then they can say like, no, we want you to correct this, or we want to change this, and it goes back to requests for corrections. And then it goes to certain ones have to go through like public review process where like people can comment on them and say like, hey, we don't want that there. We want more open space, or we want this, that, or the other thing. And then the staff will approve it, and then eventually it will get recorded as a final plat, and then they can build on it. So we have a little bit more, total plats on the map, tentative and final. We have a legend that describes all of those statuses, and then you can actually, in the top right, filter by the final status. So if you only want to see like things that are like in requests for corrections, like these are the things that are still like being corrected, you can filter your map to only show those. So let's see it in action. I didn't test this part, so we're going to hope for the best. Yes? Okay, lovely. It came up. That's great. Rupsa, how am I doing on time? Do I have like 2 more minutes?
Yes, you can show it. We don't see your screen though, just like the app, if you have opened it up. We
You
see
see, what
your
do you see?
presentation. We see your
Oh, you see
presentation.
the presentation still? Okay. We're gonna stop share, and then we're gonna reshare because I think I shared the wrong thing. I think I shared the presentation, not the screen. Okay, I see a green box. That should be good, right?
Yep.
Disclaimer. Okay, so we gotta, GIS things. It's not perfect. GIS isn't perfect. No one is. It's pretty close though. So we have our disclaimer. You hit OK, and then here is our web map. You can zoom in and out. That's fun. You can search for a plat up here. So I'm going to type in Vale, and it'll give me everything that has the name Vale in the name. You can click on it, and it'll pop up a beautiful pop-up. Well, it's not that beautiful. I would love to change this table. But it gives you your permit number here, your title, your number of lots. I just changed the aliases on these, so they should be changing soon, I hope, into parcel and lots instead of num. And then, okay, so this is this one? No, it's this one. I'm so sorry. Okay. You can do the same thing for your tentative subdivision plats. You also have this nifty little arrow that most people not in GIS miss. So there's one of two. So you can pick your subdivision final or your tentative. So this is the tentative one. And it gives you that information before the final. And there can be tentative plats and final plats on top of each other in different parts of the review process. It's a little complicated, and I don't quite understand it yet. Because planning is not my expertise. It's GIS, obviously. So I can make you a dashboard, but I don't know that I can tell you what's going on in the map. But anyways, this is our legend. We can see all the different statuses. You can filter. So like if we wanted to see the one that's deficient, we can click on deficient, and it should have filtered, but apparently it didn't. We'll fix that later on. But anyways, this is our fun little dashboard that the citizens can use to see. So like say I lived like right here in one of these parcels, I could know that they're like, hey, there's a big ol' Vale Crossing South subdivision going in. They're gonna have 701 parcels, so I'm gonna have 701 or more new neighbors if I live down here. So important for a place that is growing quite rapidly with lots of development. And I'm gonna close my share. And I did not read any of the chat messages, because I would get distracted. So if you guys have questions, Ripsa, do we do questions now or later?
Let's do the questions later. We have two more presenters today, so we can
Okay.
just please don't forget your questions, but we will come back to it with all of them together. And our next speaker is Kaylan, and she's a graduate. She graduated from University of Washington in 2024. While there, she studied environmental science, natural resource management, and staffed the GIS lab in Suzello Libraries. Recently, she has been working on her own GIS projects and taking part in Women in GIS mentorship while looking for an entry-level GIS position. Kellen, please take over, and yeah, we're excited to hear about your talk.
Hi, my name is Kaylan. I'm gonna share my screen now. Mhm. So the Zoom thing is blocking the present button. Okay, there we go. Can everyone see my screen?
Yes, we can.
Awesome. I'll get started. So like I said, my name is Kaylan Soares. This is my project Bogged Down, and I will be going through my prediction and analysis of 40 years of cranberry masses in the United States. And I want to give a special shout out to my mentor, Jennifer Murdoch. She's been super helpful during this project, and especially with helping guide the analysis and practicing for the presentation. So a special thank you to her. I'll get started. So this project was actually inspired by a memory I had from when I was little. I saw a couple of people from Boston in the chat. One of them is my dad, but I don't know if anyone else from Boston might remember this, but there is an Ocean Spray cranberry bog located behind the Bass Pro Shops at Patriot Place in Foxborough. And I remember like going across the bridge and looking at the bog, and this memory just made me think and wonder, is there potentially a way for me to quantify cranberry growth using satellite imagery? So I started doing some research and I came across a paper from 1996. And the paper included an equation that calculates the rate of cranberry fruit mass gain in grams per day. And the function is it's a function of the hottest days in August and the hottest days of July of each year. So AMT in the equation represents that August average maximum temperature, and J30D is the number of days in July where the temperature exceeds 30 degrees Celsius or 86 degrees Fahrenheit. And as you can see, the units for the rate are in grams per day. So I thought to myself, I wonder if I could find a way to predict the number of days a cranberry will be growing for to calculate the mass. And through more research, I was able to find a paper that gave me some information on how to manipulate the equations to do just that. So the final equations for the mass of a cranberry is a function of the rate and the number of days until harvest. And I will show you how I did that math a little bit later. But after that, I was left with two questions to answer. Where are the largest cranberries growing? And are operating cranberry bogs located where these cranberries are the largest? So I set up my project from there. I started out with creating a habitat mask. This is because there's technically only 5 states in the United States that are producing cranberries and are reported by the USDA. This is Washington, Oregon, Wisconsin, New Jersey, and Massachusetts. Since I was doing a hotspot analysis, I only wanted to include this data in the analysis, but I also wanted to further refine the data by creating a another habitat mask that's based on different habitat parameters that I created. So I'll get more into that in the next slide. After that, I had to calculate the cranberry masses. As I said, this is a function of the rate and the number of days until harvest, but I had to find a way to put this equation and all of the equations that made up those variables into JavaScript code. I'll show you guys a little bit of that later as well. And then after that, I had to export the raster data that I created, and I want to give another shout out to my mentor, Jen, for helping me out with file management a few months back. It came in really handy with this project. I knew I was going to be using ArcPy to do my imagery cleanup for the hotspot analysis. So I wanted to make it easy on myself and just make it so when I run the code, I could just change the year or change the state and click enter, and that was that. So I had to make sure everything was named correctly in the right folders and in the right databases and everything. So that was a fun project. And then after that, I ran the hotspot analysis actually in ArcPro. This was my first time doing hotspot analysis. This was my first time creating a space-time cube. As I said, I used ArcPy to create all the mosaics, and then I ran the create space-time cube tool and ran the hotspot analysis. I had to end up adding the time data manually because it was not working when I was exporting it from Google Earth Engine. So I just added it manually. It only took a few minutes, so it was a quick process. And then lastly, I created a map to compare the hotspots to the actual bog locations. So as I said, I set up a habitat mask, and these are the 5 parameters that I was actually able to quantify using code. So the first one is that the bogs cannot be on impervious surfaces. This is pretty self-explanatory. Roots can't go through concrete. The second one is that the elevation has to be below 1,070 meters. This is because studies show that cranberries are actually pollinated best in low elevation woodlands, and 1,070 meters is the threshold for that. Next, the soil pH cannot be too acidic. It has to be between 4.2 and 6.5. Technically, it should be between 4.2 and 5.5, but studies show it can go to 6.5 if it's under stress. But the soil pH has to be within this limit because the nutrients essential for cranberry growth are most abundant within this soil pH limit. Next is the next 2 parameters are specific to cranberry growth. So cranberries go through a period called dormancy where they're dormant. This is when the plants are initially flooded. It occurs between November and March. Sometimes ice will form to protect the roots and the leaves on the plant so they're not damaged by the outside cold. But cranberry plants need a certain number of hours at these low temps to develop properly. And the next threshold is growing degree days. So this is a way farmers use to track plant growth and plant growth stages. The best way I could describe this is an analogy of how we measure dog years, where 1 human year is equal to 7 dog years. Growing degree days are the plant version of dog years. Those 1,750 days are taking course over a month of around 4 months in human time. So I wanted to get a little bit more into the growing degree days because this was some of my favorite math that I did in the JavaScript code and something I was most proud of. I won't bore you with all of the coding details. It's a doozy. The main takeaway I want you to have from this is that the way I'm doing the math is taking images and manipulating bands to create new images, and those new images end up being my variables in the equations that I'm running. So this chunk of code created an image collection for my growing degree days layer. One thing to note about Google Earth Engine image collections that will make this graph make more sense is that Google Earth Engine image collection is a collection of images where each image represents a specific moment in time. So this growing degree days layer, each image represents a day between March 1st and November 1st. And then this graph is from a specific location in central Wisconsin. I put the coordinates right here. So this graph represents the data from that specific location. So when I created the growing degree days layer, I added 3 bands to the layer, one with cumulative degree days, one with the days since the cranberries left dormancy, which is March 1st, and one with the number of days until harvest. My logic behind this was that when we got to the threshold of 1750 growing degree days, which is right here, you could go down and capture the number of days until harvest and then plug that in to the mass equation to calculate the mass, which is what I did right here. In this block of code, if you look down to the highlighted lines 1223 to 1226, this is me running the mass equation to create the mass image that's on the bottom right hand of the screen. So in line 1223, I added in the rate data. In 1224, I added in the number of days since harvest. And then in 1226, I multiplied those two things together to create the mass image. And this is what a Google Earth Engine image comes out to. One thing to note about this image is these are potential cranberry habitats, which is why it's not just the 5 states that I mentioned before. These are potential areas that cranberries can grow all across the United States. And in the darker areas is where the masses are higher, lighter areas are where the masses are lower, and then the blacked out areas are the areas that are masked out and cranberries cannot grow there. Technically, the habitat's not viable. And the same logic goes for the rate image, which is up at the top. I know these images look very similar, but if you look closely, you can see slight color differences, some down here, a little bit up here at the tip of Minnesota, and then he has some over here. And then, so I created a mass image, this bottom right-hand one, for every year between 1985 to 2025 to run my hotspot analysis. And I explained how I brought that all into ArcGIS Pro, and I created this map. So for this map, the aesthetics I'll get into first. I really appreciated how the hotspot analysis symbology looks like you're looking at an aerial or satellite image of a bunch of cranberry bogs. I thought that was really cool. And the small red hollow dots represent the active cranberry bogs that are located within the state of Wisconsin. And I did hollow symbology so you could still see the hotspots throughout. And you can see that the bogs are located near some of the oscillating historical hotspots. For this map, there isn't a major hotspot or a major cold spot. There are more oscillating hotspots, historic oscillating hotspots, and historic oscillating cold spots. This means that these areas here could potentially produce larger cranberries historically. And then I made sure to add all of the sources and a little bit of information about how it was calculated. So if someone were to stumble across this map out of context, they would know a little bit about what's going on here. And then here are all my links. I put up a GitHub repository for all the code for this project if you wanted to check it out. I did my best to explain each step with comments in the code. It could be a fun way to get introduced to the JavaScript Google Earth Engine API. It's a really fun technology. You can do a lot of really cool stuff with it. But that is all. And thank you so much for listening.
Well, that was very interesting, Kaylan. Great job and such great use of tools. Loved it. If you have any questions, we'll have a Q&A session after this. Kaylan, like right after school, this is so high level work that you're doing. Really impressive. Thank you for
Thank you.
presenting with us today, like really.
Thank you so much.
And next we have Jami Temes, and she has some really fun presentation for us today. Jami, please take it over, introduce yourself, and let's hear you out.
Okie doke. Hi, everybody. My name is Jami Dennis. I am, you might see my name around because I am the chair for the Women in GIS Outreach Committee. But I've also been in GIS for I'm going to just say 20 plus years, even though it's a lot longer. So what I'm going to talk to you today about is using R and census data. And so my background when I started with GIS was I did a lot of demographics. So I'm a census, I'm a demographic nerd. So I love that kind of data, and I've had a lot of different experiences with it. So I want to jump right in here. Share my screen, of course. Hopefully I will share the correct one. All right, I think you're seeing the right screen. All right, so I'm going to talk to you about leveraging R and TidyCensus. And I know that sounds kind of boring, but really, this presentation is really about a tale. It's a tale of data, of maps, and of heroic code. So I want to rename it, and I'm going to call it Census Crusaders to the Rescue. So, because you know, programming can be a little dull. So I'm going to tell you a story. So this starts out maybe a little bit like a fairy tale, but really it's based on a true story. This actually is true. So once upon a time, I was frustrated. I was struggling. I was just at my wit's end. And if you've ever used census to date data before and had to go through data.census.gov and pour through all that stuff, you probably know that the struggle is real. I mean, I know you guys today, we can get stuff off, GIS folks, we can get stuff off of the Living Atlas pretty quickly. But if you need some uncommon data set, like the number of women between the ages of 15 and 50 who had a birth last year, then it becomes like this crazy chaos thing. You're searching, you're downloading, you're cleaning data, you're formatting data, you're joining, you're it's chaos. And I would found myself in that position. I thought, you know, I just need a hero. I mean, Cinderella, she had these little heroes, and she had them, and they helped her turn into a beautiful Disney princess. I mean, I was not asking for royalty. I wasn't asking to be a Disney princess. I just wanted a little hero of my own to help me through the chaos. Was there one out there? To my surprise, along came our hero. And our hero showed me the power of R programming. Okay, it's a programming language, it's free, it's open source, it's powerful, and best of all, it does not crash when I throw 1,000 census tracts or 2,000 block groups at it. It just sticks around and hangs out. But you know, our hero couldn't do it alone. I mean, I need a lot of help. If you know me, I'm going to need a lot of help. So poor our hero, like any great superhero, is even more powerful with a couple of sidekicks. So our hero brought along her two amazing sidekicks, Tidy Cat, no, not the kitty litter, and Arc Cat, not short for Arc Catalog. Tidy Cat here showed me the power of TidyCensus, which is an R package that pulls census data and the associated geography all in one step. And ArcCat then showed me how adding the R ArcGIS bridge will allow me to send census data straight into my geodatabase. None of this searching around, finding something on Living Atlas and all that. No downloads, no headaches. It's amazing. And I'm going to show you how it works. First of all, our hero showed me where to find R and RStudio, because you kind of need those both. Actually, you do, not kind of. You need both of these. It's a simple download, and install them both to get yourself started. So I did that. Got it all started. And then opened up the RStudio package and installed the necessary packages. So what you'll need, or what I needed to do this particular thing, are Tidyverse and TidyCensus, which are some packages you're definitely going to need. And then DP Layer, which is for some data wrangling stuff, and SF, which stands for Simple Features to support reading, writing, manipulating spatial data. And then the SP package, which provides classes and methods for handling of spatial data. So those basic ones you install right there from RStudio package. quick and simple. But it doesn't stop there. So our hero got me set up with RStudio and the R programming language. And then TidyCat jumps in. And TidyCat says, hey, you're going to need to have a key to get into the census stuff. But it's not that big of a deal. It's okay. It's free and it's permanent. So all you got to do is go over to the census website and grab yourself an API key. It's free, it's easy. You register once and then you can use the code or the API key in all of your R scripts when you want to get census data. Voila. So TidyCat, great sidekick. Then here comes ArcCat. ArcCat pounced in and said, hey, before you can get anything into your GIS, you're going to need a bridge. You're going to need a bridge to send that census data directly into ArcGIS Pro. And how you do that? Another super easy thing. I couldn't believe it. If you're using ArcGIS Pro desktop, you simply go to your project options. There's under the little geoprocessing tool there, if you can see that there on the left. Open it up, scroll down a little bit there, and you'll see our ArcGIS support. It'll detect R already installed on, because you've done that first, right? We did that where our hero taught us that. And then you just install it from the internet. Takes a few, pretty quick, and you've got the bridge all there. Voila. Now we go back and write the script. So all those preliminaries are out of the way. Our hero now is telling me how to get started writing my first script. So you just open up RStudio and start going. Pretty simple. These are the preliminaries there. And then TidyCat walked me through loading of the ACS variables. All those ones that I'm going to need, I'm going to use into a named character field right here. All right, so these are the variables. For this example, we're just getting some simple stuff, population and the number of males and females. Then you go on and use this cool get ACS function, which this is one of TidyCensus superpowers. Okay, you just use this, name the geography you want and the variables right inside there, and it's going to fetch all of it. And especially if you have geometry equals true, TidyCensus will include the geometry. So your data set will be mappable right away. So when you're in RStudio, you can set up this quick little simple little script, run it directly right into RStudio, and you'll get a table. So you can look at the output before we're going to map it, right? So all the columns you see are clean here. And I'm going to, it's a pretty wide table. So I'm going to click to show you what's happening over here on the right. You can see that I've got my total population. The E stands for estimates. The M stands for, if you're a census data nerd, you know that stands for margins of error, or MOEs, as some of us call them. So you have the MOEs, MOEs, and the geometry. So that's where all the magic is. So everything's included, and I'm ready to explore the data that R has sent me and send it straight to my geodatabase and map it. Oh, wait a minute. ArcCat jumps in and says, whoa, warning, warning. Geodatabases do not like periods in your name, field name. So variable cannot have a period in it, or else it's going to throw up all over you. So what you need to do is you're going to have to fix that little thing. So go back over to your R code real quick, decide if you want to keep them or not. I decided I didn't need that name.x thing, so I dropped it. And then I decided the long name might come in handy, so I just renamed it. Easy peasy. Then add this one little piece of code right here to write it to a geodatabase. The arc.write command sends it to a file geodatabase in seconds. You hit the run, no manual joins, no cleaning of data, no geoprocessing tools. It's all right there. And I pop over into ArcGIS Pro. Voila! All my data is right there. It's kind of tiny there, but basically what you see here is one record that has each one of those columns that you saw on the table in R are now here. Here's my map with all these amazing block groups, and the data is straight attached to it. Easy peasy, just like that. It's done, mapped, ready to go. I mean, come on. How heroic is that? I cried when I saw this, when I learned this. It was amazing. So really, you guys, The next time you find yourself in need of census data for your GIS project, get this trio of superheroes, the Census Crusaders, TidyCat, the key master for unlocking all your census data, ArcCat for bridging your data into a geodatabase, and of course, our hero, the wizard of all the coding powers. And so you too, with these three at your side, you too can join the elite and become a Census Crusader just like me. I know, applause now. Go ahead, I see it. All right, so that is the story on how I became a Census Crusader. And I know I threw a lot of little links out there, so I do have this one last little slide if you want to take a screenshot to get all the links of where everything is that I found. So it's simple, it's quick, and I zipped right through that, so I've got lots of time for questions for all the other presenters too. Thanks, everybody.
Well, thank you so much, Jamie. That was so fun. Love, love, love the presentation and such cool tools, like really. I am, unfortunately, I just lost power here. So my laptop is going to shut down soon. I would, if you have questions, please start speaking up, and you guys are in great hands. Yeah. Jamie and Sam, if you don't mind, like taking over the Q&A before my
Okay,
laptop shuts down.
since I'm so shy, I'll jump in. Does anybody have, let's see, we started with Sam. So anybody have questions for Sam? I muted myself.
I think I got lucky and no one has any questions for me.
All right. How about cranberry questions for Kaylan?